first bit with the first bit, second bit with the second bit, third bit with the third bit, and so on. This is what will happen. Is this clear? So the value of Z is the result of the logical AND of X and Y. Is this clear? We have the same for OR, and we use this operator, this bar, vertical bar. What else? We have the XOR. We use this caret, or I don't know how they call this symbol. So I can write Z is equal X, Y. So this is XOR. We have the NOT as well, the tilde. Of course, the NOT, we don't do X, not Y, right? This is wrong. So Z is equal, not X. So if I do this, I will get in Z the ones complement of X, right? The opposite of X. So Z is equal not X. So each bit will be inverted. Each bit of X will be inverted and assigned to Z. And then we have the shift operators. We have the right shift and the left shift, which are similar to the ones that we did in VHDL, in digital. Right? Do you remember? So those are the operators that we use to manipulate bits in C. Those are like the truth tables of the. So this explains what I was explaining before as well. Here, if we are talking bit and bit, just one bit, yeah. So if for X we have 8 bits, so we said the first bit with the first bit, second bit with the second bit, third bit with the third bit, and so on. And this is the, so if bit X is 0 and bit Y is 0, I will get 0 as a result. If bit X is 1 and bit Y is 0, I will get 0. This is like the truth table for an AND. Is this clear? Same for OR. 0 or 0 is 0. 0 or 1 is 1. 1 or 0 is 1. 1 or 1 is 1. Right? And then we have the XOR. The XOR, we know that if the bits are different, we get 1. So 1, 0 is 1, and 0, 1 is 1. The other cases is 0. So 0, 0 is 0, and 1, 1 is 0. And we have the NOT. If the bit is 0, we do NOT, then we get 1. If the bit is 1, if we perform a NOT, we get 0. I think we know this, yeah, from digital. It's just now if we have an 8-bit number and an 8-bit number, we just do bit by bit. First bit with the first bit, second bit with second bit, and so on. Is this clear? So I can show you an example quickly before we move. Let me copy the example that I have here. We'll do it as an exercise. So you tell me what will happen here. All right, let's put back the. Yeah, if I write this code. So I declared 2 variables, 4 variables actually. So X, Y, Z, and W. Then I did initialized X to 15 and initialized Y to 240. And then I did Z is equal X or Y, and W is equal X and Y. So what do I get in Z and what do I get in Y? Oh, sorry, the W. So what will be the answer or the result in Z? Can you do this and let me know the answer? So X is 8-bit. All of them are 8-bit. Can someone answer the question? The first one, for example, Z.
First one would be so the binary would be all ones. So in hexadecimal it would be FF.
In decimal, because we are displaying in decimal here, right?
It will be 2 to the power of 8 minus 1.
255.
Yes.
Okay, and the other one?
0.
0. Yes. First one is, the binary is correct, but it will not be displayed as 255 because it's signed. So it's -1. When all bits are 1, you do the choose complement, you'll find it's -1, right? Because char, we didn't specify signed or unsigned, right? So we didn't specify if it is signed or unsigned. So by default, you know that by default is signed, right? So it's like signed char. Now the result, as you said, is all bits are 1. This is correct. When all bits are 1, this means the last bit is 1, the number is negative. And what is the negative number? Is -1. When all bits are 1. Now if I want to display 255, I will just add unsigned here. Now if I do unsigned operation, and the result will be 255. And the other one is 0. It will not change. It's 0. Now it's 255 because it's unsigned. And this is very important. Yeah? If you display in hexadecimal, you will get it one FF, as you said, for both cases, because it's hexadecimal. Right. So this is for the, is this clear for the rest? Because I'm always getting the same elements participating, and I want to hear from others. I don't know if things are clear or not clear. And since I'm not getting any questions, you are quiet, this means that I assume things are clear. And I wish I will get other students to participate, yeah? Right, so this is for the, it's a normal and or, you know, not, and you can try them anyway. You can have examples and you can just run with, even with the simulator, and then it will give you the result. Change the sign, signed, unsigned, and you will see the difference. Right, now back to the, how do we use those operators? The example that I gave you, just a simple and or. Now, how do we use them to, for example, set a specific bit? If I have an input, I get the input, and I want to change just one specific bit in my code. So set it to 1. When we say set is to 1. How do we do this? So we use the bitwise OR operator. So we use the OR. So for example, here to set bit 0, port A here, I just call it port A, is like a variable in your code. So it could be X is equal X or 0, 0, 1. So I have, let's say that port A is char, is declared as char. I'm working with 8 bits in this lecture, but the same applies to any number of bits, to 16, to 32, or whatever the size. It's the same logic. So char port A, and then we guess this port A as an input, and then we want to change its first bit. So I have 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So it's better to put the number of bits here. 0, 1. I didn't put it in the table below, but this is what I mean, yeah? 3, 4, 5, 6, 7. So those are the bits of port A. Bit 0, bit 1, bit 2. So what I want to do is to change I want to keep all those bits as they are. I don't want to change from bit x1 to bit x7. I don't want to change them. Sorry. Just want to change the color. But what I want to do is just to change this bit x0. So the result, I want the result to be x1, x2, x3. So I'm not going to change them. X1 could be 0 or 1, x2 could be 0 and 1. Those are variables. I'm getting the value of port A. I don't know what is the value. I don't want to change them. But I want to just set this bit to 1. I want an answer like this. I want 1, and then, so I have to make sure that the first bit is 1. How do I do it? By using the bitwise OR, and then I need to find what we call the bitmask. So I will do port A or 1. So if I do 1 here, 0, 0, 0, 0, it's an OR operation. So I'm doing this OR with port A, this one and this one, right? So this is what I want to do. X0, X1, X2, X3, X4, X5, X6, X7. I want to do OR, logical OR with 1, 0, 0, 0, 0, 0, 0, 0. So what do I get in the first bit? If x0 is 0,